Hello students, so in this set of videos we will talk about the compound angle formula and some of its applications. So let's start with the sine of two angles, okay? And I'm going to use the two Greek letters to represent the two different angles, alpha and beta. And what is the sine of the sum of alpha plus beta in terms of alpha and beta? So what I've done is I've constructed a triangle, one triangle that has the angle alpha in it, and this is a right triangle. And similarly, I'm going to stack right on top of it a right triangle again that has the angle beta in it. Okay? And let me label the sides as the following. So A, B, C, D, and E. And we know very well by now that sine of the original angle alpha would simply be the opposite side over its hypotenuse, which is A over C. And similarly, sine of beta would be its opposite side over its hypotenuse, so D over E. Okay, and what we are trying to find is what is sine of the combined angle alpha plus beta, so this angle right here. Okay, so what I want to do is to try to express this this quantity in terms of A, B, C, D, and E. Okay, so how would I do that? Well, I know that the combined angle alpha plus beta is going to be equal to a triangle that is comprised of that angle, its opposite side over its hypotenuse. So I can construct two potential triangles that would allow me to calculate that ratio. And here's what I mean. So what I've done is I've constructed two right triangles that has the angle alpha plus beta. And one is the red triangle. As you can see, is a right triangle, and it would have the sine of alpha plus beta is going to be this side divided by that side. Similarly, I can also use the orange triangle, which I've constructed, and sine of that angle is going to be this side divided by that side, right? So which triangle should I use? Well, if you notice, the red triangle is going to have two sides that are represented by unknowns. Okay, unknown meaning that is not related to any of the quantities A, B, C, D, or E. Okay, so I have both the opposite sides, this part here, that I'm going to have to try to figure out, as well as this portion here that I'm going to have to try to figure out. So that's going to be a little bit more problematic for me. Whereas on the orange triangle, I only have this side that I need to figure out because the hypotenuse is still E, okay? So I'm going to try to use the orange triangle because it represents simpler, potentially a simpler path for me. Okay, so let's try that. Okay, so what I've done is I've cleaned up the diagram, and I'm going to retain only the orange line here. Okay, and the sine of the angle alpha plus beta is going to be the length of that orange line, this line right here, okay, divided by E, right? Its opposite side divided by its hypotenuse. All right, and just to make sure that we both understand, this line, orange line, is perpendicular to the base. Okay. All right. There's one more piece of information that we need before we proceed further, and that is I'm going to tell you, and you can prove that to yourself, that this angle here is also alpha. Okay, and you can prove it using similar triangles or using complementary angles. So I'm not going to get into that, but that is going to be key in my derivation. Okay, so that angle is alpha, and furthermore, I'm going to break that orange line into two sections now. I'm going to call this L, and I'm going to call this section M. Okay? All right, so with that, I think we can continue. Okay, I just corrected one of the inconsistencies between this diagram and the very original one. So this side is A right here, and that side is B. Okay, so we can continue now. So what is sine of the angle alpha plus beta using the orange line as the opposite side to my right triangle? So that is simply going to be equal to L plus M, right? That length of the whole total orange line, divided by its hypotenuse, which is E. Okay, so now let's figure out what L and M are. Okay, using this triangle right here that I'm going to highlight in red now. Again, this is a right triangle with the angle alpha sitting right there. So I can write the relationship between L and D using my cosine function. So cosine alpha is going to be equal to its adjacent side over its hypotenuse, right? So therefore, cross multiplying, L is going to be equal to D times cosine alpha. All right, and I'll save that for future use. Okay, so let's keep that in mind. What about M? Well, M is equal to A, right? Because this thing here is basically a rectangle. So opposite sides are equal to each other. M therefore is equal to A. But I want to somehow relate A back to C. Okay, well, we have it right here, right? Sine of alpha is equal to A divided by C. So I can write A is equal to C times sine of alpha. Okay, so therefore M, since it's equal to A, is also equal to C times sine of alpha. Okay, and I'll save that for future use as well. Now, I'm going to plug in all those quantities into this formula. So sine of the combined angle, alpha plus beta, is going to be equal to L plus M, and L is D times cosine alpha, M is C times sine alpha, all divided by E. Okay, and I'm going to split the fraction now into two parts. So the first part is going to be D times cosine alpha over E, and the second fraction is C times sine of alpha over E. Okay, and then I can separate out this part, right? D divided by E as well as C divided by E. Well, what's D over E? Well, D over E is sine of beta, right? This is sine of beta. And what about C over E? C over E, if you look at these quantities there, that is cosine of beta, right? So finally we arrive at the conclusion that is equal to sine beta cosine alpha plus cosine beta sine alpha. Okay, I'm just going to rearrange the terms a little bit. So we arrive at the very familiar identity, sine alpha plus beta is going to be equal to sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. Okay, so this is the angle sum identity for sine. And using a similar technique, you can also derive cosine of alpha plus beta, and that is going to be equal to cosine alpha cosine beta minus sine alpha sine beta. Okay, so these are the two identities. and I'll leave the proving of the cosine or the derivation of the cosine for you as an exercise.